All right, let's talk about this worksheet. So, first of all, up here at the top, this wasn't graded, but just so we're clear, so the letters PH, it tells you represent the French words, which stands for hydrogen power. Oftentimes you'll hear it referred to as the power of hydrogen. So the definition of pH is the pH is equal to the negative log of the hydrogen ion concentration of a solution. Okay, so if pH is the negative log of the hydrogen ion, then pOH is the negative log of the hydroxide or OH negative concentration of a solution. Okay, remember, so logarithms is the power to which 10 must be raised to equal that number. And we can do this in our calculators. So a pH value of less than 7 indicates an acidic solution, 7 is neutral, anything more than 7 is a basic solution. Alright, so we have 5 problems here, and this was our first assignment on this, part 1, where you had to determine the pH of a solution. So when you're reading one of these and you're asked to find pH, you've got to pay attention to what's given to you in the problem. So I want you to find pH. It gives you a 0.010 molar HNO3 solution. So notice this starts with an H, okay? So what this tells me is we have an acid right here, okay? So if we have an acid, we have that proton, we have the hydrogen ion, so all we have to do is the negative log of the concentration given to us. Easy peasy, get a pH of 2. Okay, same thing here. Notice we are asked to find the pH of a concentration of HCl. That's got a hydrogen at the beginning. We know this is an acid. That H is going to be donated, so we get a pH of 5.6. So now we're asked to calculate the pH of a 0.0025 molar H2SO4 solution. We've got H's there at the beginning. We've got an acid. Going to donate a proton, so all we have to do is pH is the negative log of that. 4 and 5 are different. A lot of you miss this, so let's talk about this. Pay attention here. We are asked to find the pH of a NaOH solution. This is different. This isn't an acid. This is a base. So when we do pH as the negative log, we can't do that for this one. We can't just do pH as the negative log because this doesn't have an H in it. Okay, so we don't have a proton to donate at the beginning. We have hydroxide, so we have a base. Okay, so we don't have that H at the beginning to be donated. Instead, we have a base that's going to receive a proton. So here's what we do. We solve for the pOH. Okay, and we know that pOH is the negative log of the hydroxide concentration. So we solve for the negative log of this. That gives us a pOH of 3. Most of you guys stopped here and said pH is 3. Not true. Okay, pOH is 3. We know that pH plus pOH is equal to 14. So if we take 14, subtract 3, that'll give us what the pH is. So we get a pH value of 11 for this problem. Okay? So why did we do this one differently? Remember, all of the other problems gave us an acid. Started with an H. This one did not. It gave us a base. It has hydroxide in it, and it doesn't start with an H. Right, so that's how we know. Number 5 is the same way. Most of you missed number 4. You also missed number 5. Okay. What is the pH of a SrOH2 solution? Once again, we've got hydroxide. We've got a base. So before we can find the pH, we have to first solve for the pOH. Right. So the pOH is equal to the negative log of the hydroxide concentration. We know that this concentration will be the hydroxide concentration. So we solve, we get a pOH of 1.7. 14 minus 1.7 gives us 12.3 for our pH value. So be super careful with that. If I had asked you for just the pOH here, not the pH, and said find the pOH, you would only do this first part, and the pOH would be equal to 1.7. Right, so pay attention there. On these first 3, if I'd asked you for pOH, okay, we would go through the same process. We'd find the pH, okay, using the H plus concentration, and then we would take 14, subtract 2.6. That would give us our pOH value for those if I had asked for that. All right, let's take a look at part 2. Number 6 and 7. Most of you did really well on this. So let's run through it, just make sure for any little mistakes we might have made. It says find the hydrogen ion concentration in an HCl solution with a pH of 3.0. So remember, for these we're working backwards. So we're going to find the hydrogen ion concentration, we take 10, raise it to the power of the negative pH, right? So we have a pH of 3, so 10 to the negative 3.0 gives us a concentration of 0.001 molar, or 1 times 10 to the negative 3. I like this one better, the 1 times 10 to the negative 3 for this particular problem, and we'll see why in just a second. For part B, what is the hydroxide ion concentration of the same solution? Well, we know, remember, that pH plus pOH equals 14, so all we have to do, right, take 14, subtract our pH of 3, that tells us the pOH is 11. So once we know the pOH, now that we know that, we can solve for the hydroxide concentration. Okay, so hydroxide works just like the hydrogen ion does. So 10 to the negative pOH is equal to the hydroxide concentration. So we're going to say 10 to the negative 11. We get this value. The next question says, which ion, H plus or OH negative, is in greater concentration? Pretty straightforward question, but a lot of you miss this question. So remember, OH negative is 1 times 10 to the negative 11. It's in scientific notation. So if one number is in scientific notation, it's better to have them both in scientific notation, or both as a decimal. Put them in the same form so that you guys can see them. Most of you that missed it didn't have them in the same form. 1 times 10 to the negative 3 is a much bigger number than 1 times 10 to the negative 11. So the H plus, this is a much bigger number, okay? A lot fewer decimal places here than this one, right? So I think you guys just looked at that exponent and went from there. So be careful with that, because those are negative exponents. We have to be careful. So is this solution acidic or basic? You guys did great on that. It is an acid because it's got a pH of 3. Number 7. Find the H plus and the OH negative as a solution with a pH of 3.494, which is a few too many digits, but we're going to work with it. Okay, well, finding the H plus, not so bad. We know that the hydrogen concentration is equal to 10 to the negative pH, so 10 to the negative 3.494, we get a hydrogen concentration of around 3.2 times 10 to the negative 4. Okay. 14 minus pH is equal to pOH. We talked about that. If we add them together, we get 14. So we're going to take 14, subtract 3.494. We get 10.506 for pOH. So for that, we're going to take 10, raise it to the negative 10.506 power to get the hydroxide concentration. Remember, that relationship is just between the pH and pOH. Right, so we get a hydroxide concentration of around 3.12 times 10 to the negative 11. Now, is this solution acidic or basic? Okay, well, we know that the the pH was 3.49. That tells us we've got an acidic solution. So always base whether a solution is acidic or basic on the pH value, okay? Just to keep that straight. So always use the pH value to determine that.